All right, let's dive in. Today, we're tackling one of the biggest names in the data world, Apache Kafka. If you've ever wondered how massive companies, think Netflix, Uber, you name it, handle just mind-boggling amounts of data in real time, well, you're in the right place. We're going to break it all down.
Okay, so picture this. You've got a growing company, right? Data is just flying everywhere. You've got user clicks from your app, orders coming in, updates going to databases, the works. Now, the instinctive thing to do is just connect everything directly. Your app talks to the database talks to the analytics tool, that tool talks to another service, but pretty soon, what do you have? You have an absolute nightmare, a tangled mess of connections that's just waiting to break. And that tangled mess, that is exactly the problem Apache Kafka was created to solve. Instead of that point-to-point chaos, Kafka steps in and becomes this central hub, this data superhighway for everything. The analogy on the screen is perfect. It's literally the central nervous system for all your data. So this whole central nervous system thing sounds cool, but how does it actually work under the hood? Let's peel back the layers and look at its core components and architecture. Right, before we can really grasp the big picture, we gotta learn the lingo. Every technology has its own vocabulary, and Kafka is no different. So let's start with the absolute fundamentals, the building blocks of this whole system. Okay, let's run through these real quick. First, you have a topic. Think of it like a spreadsheet tab or a folder for a specific kind of data, say user clicks or new orders. Simple enough. But what if you have a ton of orders? Well, you split that topic into partitions to handle the load. It's how Kafka scales. Now, where do these things live? They live on servers called brokers. A broker is just a single Kafka server. And finally, every single message that goes into a partition gets its own unique ID, like a serial number. That's called an offset. And boom, here's how all those pieces fit together. This diagram is great. Over on the left, you've got your producers. These are your apps, your services, anything that creates data. They're writing messages into those topics we just talked about. In the middle, that's your Kafka cluster, made up of all the brokers and partitions that are storing the data. And then on the right, you have your consumers. These are the apps that need to read that data to do something useful with it. Now, let's zoom in on what a partition actually is. This is super important. It's not just a messy bucket of data. As you can see here, it's an ordered, unchangeable log. That means new messages only ever get added to the end. And that offset, it's basically a bookmark. A consumer can say, hey, I've read up to offset 10, and Kafka knows exactly where that is. The consumer can crash, restart, and it never loses its place. It's a simple idea, but it's incredibly powerful. All right, so we've got the vocabulary down, we know what the pieces are called. Now let's see how they all work together in a dynamic way. Let's talk about the actual data flow. Okay, so let's get practical. How does an application, your actual code, produce and consume data with Kafka? What are the rules of the road? Let's dive into that now. At its heart, it's dead simple. You've got producers that write events, and you've got consumers that read them. But here's the magic trick, the most important part, they are completely decoupled. The producer has no idea who's listening. It just shouts its message into the void of the topic. This is a huge deal because it means you can add new consumers, change existing ones, or take them offline, and the producer just keeps on chugging along, completely unaffected. That's what gives you all the flexibility. This brings us to a really key concept, consumer groups. This diagram shows it perfectly. Take a look at consumer group A. See how its two consumers have split the partitions of the topic between them. They're working as a team to process the data faster. That's how you scale your consumption. But now, look at consumer group B. It's a totally separate team, reading the exact same data from the beginning, but for a completely different reason. Maybe group A is updating a database, and group B is feeding a search index. This one concept lets you do both load balancing and broadcast messaging. It's brilliant. So when your producer sends a message, how can it be sure it actually made it? I mean, what if the network glitches? Well, Kafka gives you this really neat control knob called ACKs, which is short for acknowledgements. Think of it like a durability dial. You've got ACKs equals 0, just fire and forget. Super fast, but you might lose data. Then there's ACKs equals 1. Wait for the main server to say, got it, a good balance. And then you have ACKs equals all. Don't move on until the main server and all its backups confirm they have the message. Slower for sure, but as safe as it gets. And this diagram really nails that trade-off. See? With ACKs equals 0, the producer sends the data, and that's it. It just assumes it got there. With Ax=1, it sends the data and waits for just one confirmation from the leader broker before it moves on. But with Ax=all, it sends, waits for the leader, and then the leader waits for all its followers to get the data before sending that final OK back to the producer. It's all about what you need. Do you need blazing speed, or do you need an ironclad guarantee?
Now here's something you gotta remember. Kafka isn't meant to be a forever database, at least not out of the box. If it just kept everything, the disks would fill up, right? So it uses what are called retention policies. It's super simple. You can configure it to say, hey, delete any messages older than 7 days, or once this topic hits 10 gigs, start deleting the oldest stuff. It's just a way to automatically manage disk space so you don't have to.
Okay, we've got the building blocks, we know how data flows, but what makes Kafka so special? Why is it everywhere? Well, let's talk about its superpowers, because it really does have some. Superpower number 1, just insane speed. We're talking millions of messages a second. It's mind-blowing. And how does it do it? Well, it's not magic, it's clever engineering. This diagram points to 2 big reasons. First, it writes to the disk sequentially, just one continuous line. Hard drives are really fast at that. Second, it uses a trick called zero copy. Instead of copying data from the disk to the application, then to the network, it just pipes it straight from the disk cache to the network socket. It cuts out the middleman, and that makes it fly. Next up, superpower number 2, scalability. And what I love about this is how simple it is. You can start with just a couple of servers, a couple of brokers, but as your traffic grows, you just add more machines to the cluster. That's it. Kafka automatically rebalances the load, spreading the partitions across the new brokers. It's built to scale out, not just up, from the very beginning. All right, superpower number 3 is durability. Simply put, Kafka's built to not lose data. And it does this in 2 main ways. First, as we said, data gets written to disk, so it survives a server reboot. But even more importantly, data is replicated. That means copies of your data are stored on other brokers in the cluster. So if one entire machine just dies, no sweat. Your data is safe and sound on another one. And that replication is what gives us our 4th and final superpower, fault tolerance. Let's just walk through this diagram because it's a great little story. Step 1, everything's happy. Broker 1 is the leader. Step 2, oh no, broker 1 goes down. It crashes. The whole cluster immediately notices. So in step 3, one of the followers, in this case broker 2, is automatically elected to be the new leader. And just like that, producers and consumers switch over and the data starts flowing again. All of this happens automatically, in seconds. The system just heals itself. Okay, so speed, scale, durability, that's all awesome. But what does this look like in the real world? What are companies actually building with this stuff? Let's check out a few common use cases. Probably the most common use case you'll see is as the communication backbone for a microservices architecture. So in this picture, you've got an order service. When a new order comes in, it doesn't call the shipping service directly. No way. It just publishes an event like order #123 created to a Kafka topic. Then any other service that cares, like the shipping service or the notification service, can subscribe to that topic and react. The order service has no idea they even exist. That's that beautiful decoupling we talked about, and it makes your whole system way more robust. But it goes way beyond that. The versatility is just wild. On one hand, you see it used for real-time activity tracking, just hoovering up millions of clicks and events from a website so you can analyze user behavior as it happens. And on the other hand, you see this more advanced pattern called event sourcing. That's where the Kafka log isn't just a messaging system, it's the single source of truth for your entire application state. It's a game changer. So, there you have it. Kafka is what tames the massive, chaotic river of data that powers modern business. It gives it structure, flow, and resilience. It really is the central nervous system for today's data-driven world. But you know, things are only getting crazier. With AI and real-time everything on the horizon, data volumes are just going to keep exploding. And that leaves us with a pretty big question to think about. What's the next central nervous system going to look like?